Hi everyone, we're going to find information, answer these questions for a quadratic equation y equals x squared. We're going to graph it, do the table of values, and so forth. Basically these two are basically where is y positive for these two here. These two, we're really talking about in behavior of the graph. All right, and also the symmetry, when I talk about it, I'm going to do J and N together. So J and N are going to go together. And we're going to answer all these questions. So the first thing we're going to do is graph these by first doing a table of values. So when I do a table of values, I pick some that go well with this. So we have y equals x squared. And I'm going to graph -2, I'm going to plot -2, -1, 0, 1, and 2. And I just plug it in my equation, and I'm going to get 4, 1, 0, 1, 4. And then you just kind of plot them and kind of graph it as best as you can. 3 would go to 9. So if we go to 3, that would be up here, and it's symmetric, okay? All right, so the domain is all real numbers because we can put any numbers in here. So I'm just going to put the domain is all real numbers. Now the range, however, we're never going to get negative. We can have 0, but we can't get negative because we square out the negative. So the range is y is greater than or equal to 0. Okay, the zeros mean the x-intercepts. So when we have 1, 0 here, and that 0 would be 0, 0, the origin. Okay, we're doing F and G now. Where is y increasing? So where is y positive? So y is positive in both quadrant 1 and quadrant 2. So for F, y is positive in what interval? And when they're talking about what interval, they're talking about the x part. So where's y positive? Well, it's positive at 0, infinity, and it's also positive at -infinity, 0. So we can't count the 0 because it's not that equals 0. So basically this would be F, and this part would be G. This is where this one is where y is also positive. It's not negative anywhere. So basically, let's just write it like this. Y is positive in quadrant 1 here and quadrant 2. Okay? Now, we're going to discuss increasing in what interval and decreasing in what interval. So basically, what you're looking at is the end behavior. And we know that x goes to infinity here, y goes to big numbers here, -infinity, that just means larger and larger numbers, and -infinity. So that's how you want to look at it. So what we're going to say is f of x goes to infinity, so my y goes off to infinity as x goes to infinity. All right? So that part is h. Now over here we have I, and we're going to say that f of x, which is y, also approaches infinity as x approaches -infinity. So as x gets, so as we go to -infinity, y goes to infinity. And that's what you're talking about there. Okay, symmetry. It's symmetric to the y-axis here. So I can fold it on the y and it matches up. When it's symmetric to the y-axis, that means it's a even function. So it's even. So that takes care of that. Is this a one-to-one function? No, it's not. It's not a one-to-one function, because if you do a horizontal line test, it fails. It only can hit 1 point for it to be one-to-one. And what that tells us that we're going to have to restrict the domain. So what I'm going to do is come over here and restrict the domain to x is greater than or equal to 0. So when I restrict it and I draw this graph, 3 goes to 9, I'm only going to deal with this part. Because if I don't, I'll get, when I do the inverse, I won't have a function. Okay, so basically, let me draw it real quick. If you don't restrict the domain, so basically we have something here. This goes here, and this goes here. So basically, if you don't restrict the domain, when you do the inverse of this, which would be that, that's not a function. So basically we can't do that, and we have to restrict the domain so we can have an inverse function. So I'm going to restrict the domain. That means for my table of values, I'm just using 0, -1, positive 1, 2, 3, so forth. So 0, 1, 4, and 9. Now to do the inverse, what you do is switch the x and the y's. So f inverse would be 0, 0, 1, 1, 4, 2, and 9, 3. And when I draw that, 0 goes to 0 again. 1 is going to go to 1, so we're still here. But 4 then goes to 2. 1, 2, 3, 4. And 9, 5, 6, 7, 8, 9 goes to 3. So it would be like this. That's the inverse, and that means it reflects over the y equals x. Okay? Now we're going to have to do the transformation form. The transformation form is going to be y, or f of x, equals x minus, I don't know what you're going to call this, h squared plus k. And then, so that's the transformation form you need to write down. And then we're going to just give 2 examples. And the examples I'm going to use is I'm going to let h be 2, or -2, and k be 2. So I'm going to go ahead and draw my parent function again. And I'm just going to plot points here. 3 goes to 9. All right. And I'm just going to plot it. So to transform this, I have to do 2, and I'm just going to use 2. So the first thing I'm going to do is the horizontal transformation, which would be y equals x minus 2 squared. So I'm going to shift this to the right by 2. And all I'm going to do, instead, you can do the table of values, but these key points I have, I'm just going to shift everything over by 2. So I'm going over here 2, over here 2, over here 2, and over here 2. Okay, so that's your right side. Here is your axis of symmetry on this. And what I'm going to do is just make it symmetric. So I'm going to go over 1 here, over 2 here, and from here I'm going over 3. And I'm going to draw this side. Okay? So that would be a horizontal shift to the right. And then for the vertical shift, I'm just going to go x squared, and I'm going to do, let's do -2. So that means I'm shifting everything down. So I'm going to take my original, my green one, and everything go down by 2. And then after that, you can kind of just graph it from there. 2 goes to 4, so I'm going to go 1, 2, 3, 4. 2 goes to 1, 2, 3, 4. So everything just got shifted down by 2. This goes down 2, this goes down 2. So it's basically the same thing, but just shifted down by 2. All right? So there's your, the blue is your vertical shift. This would be your K. And your horizontal shift would be the shift to the right by 2. Okay? Now, that's all of this one. And the next one we're going to do is the absolute value function. Thank you and have a nice day. Bye-bye.